So, hello, Assalamualaikum. My name is Mazmin. Today we are going to discuss about the law of vector addition and its 2 points. Okay. First of all, we have vector addition by head to tail, and second one is vector into subtraction. So, first we will discuss the first case, which says basically it has two properties, which is commutative property and associative property. These properties are like this: a plus b is equal to b plus a. This is commutative. And second one we have a plus b plus c is equal to b plus a plus c. Okay, this is associative. Whenever you talk about the vector addition, remember this thing that you have to follow these two rules. Okay, so now we are gonna solve this. For example, you have vector a, okay, and you have vector b. Previously we learned about the types of vector, in which we learned about the position vector, then we have to change the positions of the vector. Okay, so same thing will happen here. We'll take this vector to this side, this tail will connect to this head, so it will become like this, like this is vector a still, this is vector b. Okay, now what we're gonna do is we will draw the line here, because this is what we say resultant vector or sum vector. Okay, which is the sum of r is equal to a plus b. It can be anything. Okay, you already know about law of vector addition, so it's basically law of vector addition. And as you know all the things about the resultant vector, so it is called resultant vector. Okay, this is the commutative property. Okay, as you can see here, a plus b is equal to b plus a plus b we have. Okay, now we are gonna solve the second point, which is associative property. So what does it mean? Like, for example, you have a vector here a, then you have a vector b here, then you have a vector c here, like this. Okay, so we'll just change the positions of these like this. Let me draw on another page. We'll draw here what we say vector a, here is vector b, and here is vector c. Now what we're gonna do is we'll just draw a resultant vector here, which will be called r is equal to a plus b. Okay, it is following the what we say commutative property. Now what we're gonna do is we'll just what we say draw a resultant vector here, which will become r is equal to a plus b plus c. So what we say, actually the thing is that this vector must be here. Okay, the vector of the position of a vector is like this, and this is the resultant vector. Okay, without this we cannot calculate, we cannot make this right. Okay, now what we're gonna do is c plus a plus b, because we have c vector here and we have already got the resultant vector here, which says which is saying a plus b. So we write here c plus, then in bracket we'll write a plus b, which means the same. So now we'll have the vector into subtraction. So what does it mean? Okay, for example, you have a vector here, vector a, okay, and you have a here vector b. Okay, remember one thing, this condition, uh, if it does allow, like if it not using the commutative or associative property, so it's okay, it doesn't need any kind of property. Okay, that's the thing, that's the case. So you'll draw here vector a, will just change the position of vector b like this, vector b, then we'll draw the resultant vector, which is saying a plus b. Then what we're gonna do is what we say, we'll just opposite the b. Okay, because we are separating, and as you know that previously we discussed that if you subtract anything, so you have to change the position, change the direction of that vector. So we'll just put here minus b vector. Then what we're gonna do is we'll draw a resultant vector here, which is saying that a minus b. So these are the, like what we say, these are the type, these are the properties of law of vector addition. In future we'll discuss about the triangle, what we say, rectangle, and their formulas as well. So for now we have already done this. Let's take a quick review. Commutative property, associative property will be used in the vector addition by head to tail rule, in which what we say, we will be given two or three vectors and you have to find the resultant vector and then you will solve. Okay. And second term is a vector plus vector into subtraction, which says that like what we say, it also has to follow the associative property. Otherwise, like sorry, it doesn't need to kind of like what we say, doesn't need to follow the commutative or associative property to for to what we say, to for solve. Okay, thank you so much.